recording. Yeah, we're here. Review. And we got that many left. That's actually not that much. So let's do this thing. Are you confident about your exam? Okay. Hmm? Oh, I think 6 o'clock is when they close. Yeah. Hey, let's talk about it. So today's Tuesday, so then Wednesday would be the last day to take it. If something if something crazy happens, you talk to me. Thursday is doable in the morning. So, but I'm not opening everything up immediately for that. That would have to be a very individual cases thing. And yeah, they should be open from all the way to 6 p.m. Get there by 4 for a 2-hour test, and there you go. You can have a whole piece of paper, front and back, for your formulas and stuff. Yep, there you go. Yeah, 8.5 by 11, if someone's wondering online. So, because they couldn't see you. So yeah, that paper. Oh yeah. And what I would recommend is putting a lot of English on there. You know what I mean? You can't put examples. You can't say blah 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 this, but like minimum sample size. Maybe you can say like take percentage, change it to Z, or maybe like go to GeoGebra and like for this particular one, and you can write down like English to help you. So we go to classic. You probably already had it up. But you could say like probability calculator, and then you would go like normal, and then you could say like left side, and I'm just saying out loud kind of like what I'm doing just real quick. I'll explain it just a second. But like you can say like left side, and then the second box put the opposite of 90 divided by 2, so that would be 10 divided by 2 is 5%. And so then you could see that that's that guy. I don't know, lots of ways to do that, without actually having an example. You can use some English, draw a couple, like a picture of a bell curve, and say like this one, or so, I don't know, your own language. Cool, cool, yeah. So now, like, what do we do here for this one? Minimum sample size is a formula, and let's go do that formula. So bloop and bloop. No, wait. Yep, that one. Okay, so here we go. We got n is equal to, and I'm trying to remember here, z times sigma all over e, then all squared. I think so. We'll see if I'm right or wrong here in just a second. And so some of these are super easy. The standard deviation, what would that be? 155. What would be my error? Again, within. Yep, the 47. And like what you can do is this formula, you can even say the word like within. It tells you what your error would be. It's kind of like, keywords and stuff like that. That from the percentage, that kind of thing. And this you could say is your standard deviation. I don't know, however you want to put it in your notes. Anyway, so we have 90%. And so on the bell curve, they're saying we got 90 here. So that leaves 5% and 5%. So therefore, we're going to like use this side because that's how GeoGebra works. 5%, well, we got the same number right there, to 1.645. Again, though, you don't have to go through all that. You could just list out and say 90%, 1.645, 95%, 1.96. Because I mean, this is the formula. That's not an example. That's like a formula. Every time 90% will be that way, So like if you want to rewrite this list how you like it, good idea. That way you don't have to kind of wonder. Does it make sense? Okay, cool. Anyways, calculator. Guess I'll pull up Desmos over here. .coms. Okay. Cool. If y'all have questions right now, y'all let me know. I know that looks a little funky, but it's still the same. So this particular one, if you remember, what do I have to do with this? Round up. Very good. Round up. For this one, for this problem, you're rounding up. Not every problem. I've told you the stories where people round up every single answer in their whole exam. No, 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 no. Just this one. Just this one. Cool. Okay, awesome. Sweet. Confidence interval. I think that we can just put all this into GeoGebra automatically. Let me try to find that. I have another thing open with GeoGebra somewhere. Is it this one? Yeah, that's good. All right. So if you go to statistics, and so this is the other things you can write down. So we're doing z estimate of a mean. So you can write z estimate of a mean, confidence intervals, right? Because that's like what we're using it for. Confidence intervals, you're going to use z estimate of a mean. And you put in your percentages. Everything should be fine here. Mean. Yep. Standard deviation. And n. Yep, you already got it. Lower upper. There you go. Again, you're not rounding here. It says 3 decimals, so like you do what they say. So even though it looks like, oh, well, that's just the whole numbers, they want you to not round until the end. Yeah, that one's a weird one, isn't it? Yeah, cool. All right, all right. Oh, they want more. Okay, well, hey, since we're here. So there's 2 questions on this one, apparently. Not too bad. Not too bad. Up, 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 up. 3 decimals still? Man. 607. And if, of course, as you know, if you're off by a decimal here, I would definitely add points. Okay, that's a 100% add points kind of thing. I don't want anybody failing because of a rounding issue. Okay, let's do this one more time. So we got the z times sigma e all squared. What would I put for z in this particular case? What do you think? You got it. So you already got it. 14 within 4, square it. There we go. My equal signs look a little bit sloppy. Times 14 divided by 4 all squared. Oh man, that's a tough one right there. 48, you're right. Man, that's a, I mean, you're like, are you sure? Are you sure? I always remember minimum sample size. You're doing like bottles of soda. How many sodas are you going to test? And so here we only need to test 5% of a soda. So you crack it open, you drink, and you put it right back on the conveyor belt, right? Everything's fine. No one's going to say anything. No recalls here, right? Just use the whole bottle. All right, cool. Let's keep cruising. So I think this was proportions, but does it say something like that? Anyways, we got data. We're going to put it in. We're going to see what happens. So is there a copy? Ooh. That'll be fun if it actually works. If you remember, we need to go back to the spreadsheet stuff. GeoGebra Classic. You can have a couple of these tabs open if that helps you. Whatever you need. Paste it in. Yeah! There we go. That was much better than the other ones. So highlight. I guess you click it a couple times. One variable analysis. You know, we've done that before. One variable analysis. This guy, sigma x, got all my numbers. But now for confidence intervals and stuff like that, see, confidence intervals, we're going to go to one of these guys. I think that it's going to be t estimate of a mean. And the reason why I think that is because if you remember, go back and forth between these two. Z estimate has a sigma. We have a standard deviation. But this one does not. So I'm going to ask you, do we have a standard deviation up here somewhere? So we can't use this one here. We can't use it because we don't have it. So you have to use this guy here. Okay. 99% confidence. If you remember, you have to hit enter for that one to change. And like it doesn't do that for the other pages, but here you have to hit enter. Lower upper, and we're done. Oops. 2 decimals? 2 decimals, yep. Okay. Sweet. Cool. All right, awesome. Copy. Paste it in. Come on, paste again. Yeah, man, that helps. If it's not pasting for you, I'm serious. Let's just pause for a second. If it's not allowing you to paste, are you going to want to type all that during the middle of exam? No, you won't. That's a time waster. So, like, if it's not working, raise your hand and say, hey, I need this to be copied in here. It worked here in class. This needs to happen. And if they're not able to help you, you tell me. You write it down on a notebook or something, okay? And walk away. But like at this point, I don't think that would be enough. That we can just talk about that problem. You know what I mean? Okay. But it should copy paste because typing this would be stupid. Don't do that. Okay. Like I'm serious. You get me? Okay, good. Me neither. So yeah, one variable analysis, sigma x, and probably this t estimate of a mean. 95 already got it. That 28, by the way, that's just the amount of folks we got, and you can see we got 28 entries there. So that's already taken care of essentially. 9 1 1 5 5 5 9. Okay, let's see it. Hit it. Yay. Cool. All right. Keep cruising. Still confident. Okay. Proportions. And I think, yeah, there it is. Proportions. There's keywords, and we're going sequentially, obviously. So confidence intervals, you got your Z's, your T's, and then your proportions. So then we're going to go back to the other one. Z, T, proportion. That's the other one there. Confidence, 99. Total of 300. Successes, 60. Lower upper, there we go. 3 decimals. We good here? I think that's going to be a 6-0. Sweet. Rock and roll, man. Rock and roll. Let's do some more. 99. Guess I already had it. Total. Selected. I'm not even asking. This is just. Oh, no. Well, we can at least get the bottom one. Whoop, Chad, I did something right. Okay. So this is the average, essentially. And they give it to you. It's right here, that 0.2. But you could just divide these and you would find that 0.2. So this little guy right here, maybe if you want, you can write on your formula card, P prime equals, and you would say interval, and then you would like circle like a thing, plus or minus, circle that. You can't use a number, but you would say first number, plus minus something, I don't know, whatever in your own words, 0.2. Standard deviation, this is SE, right? So that's easy. You could put the sigma P prime equals, and you would just say SE. Like these are the formulas essentially that we're using in this class. That would be a 3-0 if we're doing 3 decimals. This guy's the weird one, right? But if you remember, we have our table already listed out. 99%. You remember which one goes for 99%? There it is. You got it. 2.576. Yep, it's already on my list, right? So I don't have to worry. If you have to do it by hand, that's fine. We can. Oh, you know what? We can go right here. We can do that. So, huh? I guess. If you know how to read it. Good point. It's right there. Yeah, that was silly of me. Silly Chad. Hey, did you do well? You passed my class. Good job. And you're being recorded right now. Okay, cool. Well, I'll see you later. We'll be talking. Peace. All right, awesome. See, she's successful. Y'all can be too. Okay. So, We got 99% confident. Oh, yeah. Which one would it be? B. Boom. We're done. B for bum. Done. I don't know. Yeah, we're looking for true population, and I think that's the only one that says that. True population right there. Cool. We did it. We did it. That's awesome. Okay, keep cruising. Oh, we got 1, 2, 3, 4 from 9 and 4 from 12. Now think about it for a second. 9, I could definitely see it doing that, but 4 from 12? They're not hard. It's because we haven't had a test over these, so they're kind of pushing more on these than otherwise. So yes, start. Let's do this thing. Medical assistant like to test the claim. Pause. Right. So this is like, if you want me to go the whole long way, I guess, but I think that we can maybe make this shorter instead of having to do it all that. I probably should do it the long way. Anyways, okay, so he says greater than 6 point whatevers. So right here, this is the greater than. What do I put here? Just take a guess. Probably just the equals. Now it's greater, or it's less than or equal to. Technically, equals is what they're wanting here. So it said yes, just because of the graders thing up there. Blah, 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 formula, find out what's going on. So this is going to GeoGebra. So we're going to go z test of a mean, and I'm going to put in all the stuff. See, like right here, this stuff. So my mu was 6.6, and I got the greater than, and then I need to put in all this numbers. So if you go back up to the top, we got the mean, 7.2, standard deviation, 1.8, sample size, 34, and then they're looking for whatever numbers we need. Notice they're wanting a z. I think that this is the 1.94. And I'm going to verify. This is why we're practicing, okay? Like, I think, okay, good. See you later. Thank you. So, yes, that would be the z. So, like, on your paper, you might want to write, like, z0 equals, and you would just say z from z test of the mean. Something like that. Whatever in your language makes sense to you. So that one worked out fine. So that's good. So yes, we're good. We're good. Oh, we have to move it now. Did they have an alpha for us? There it is. See that? Alpha is significance level. So then I need to do that 5% business. We have a right tail test. It's been a while since we did all this. Oh no, I have to move this. Okay, so 1.94. Look at this. Come on now. No, it's like it's literally not letting me do one or the other. It's sad. I'm sad about it. Okay, I'm gonna do 3. You're totally wrong. Everything's wrong. Okay. 5. Don't. Where is it? Like, I did not say a bad word. I literally couldn't drag it over that. Okay. So when this happens to you on your test, I will add points. I will see that and add points. Okay, because that's just dumb. It's not me. I know I'm getting old, but that's not what I was doing. It was like literally not letting me do it. So that's on them, man. That's on them. Is there like a yeah? Because I'm serious. This time I'm gonna have to tell them it's like okay, like this time I'm serious. It didn't let me hover over that. I hate the autocomplete. Hover over that value. Seriously. Submit. Okay. Yeah, that's on them. Continue. Okay. Blah 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 blah. We have a p-value, and ours is 2.6. I think their p-value, their alpha was 5%. So P is less than alpha. I think that's a reject H naught, and you do support the claim kind of thing. We've done that so many times. I could do it again. I don't know if y'all want me to. You're like, nah. Do you want me to? You want me to? I could do it, man. Let's do it. I like it. You know I like sitting here talking about this stuff. Okay, I want to do like a brand new page here. So let's recap on like what we were doing, I guess, in a way. So we had our H naught and our H sub A and our mu, and that was the equals, and this is the greater than. I'm going to try to fill that in. Greater than the 6.6, 6.6. That was my claim. Awesome. And then I'm saying this is a right tail test. Sweet. And so then we did, oh, and if somebody asks, it looks like that, but we already talked about that one. Great. Okay, so then I have a P and I have an alpha. My P was the 0.026, I think, and that was back from GeoGebra. And our alpha was the 0.05, and they gave that to us. So chomp the bigger one. P less than or equal to alpha is a reject H naught. That, yeah, you put that on there. Yeah, please. Yeah, like it's a formula. It's called decision rule. So if P is less than or equal to alpha, reject H naught. And if P is greater than alpha, you're going to fail to reject H naught. Yep. No, yeah, definitely. I mean, it's somewhere in the workbook. I can't remember where, but it's somewhere there. So then what we do is say, reject H naught. So we reject this thing, and so we say yes or no support for the claim. And it looks like we do. It says yes support. That's good. Cool. Yes, that's what we're doing. I do recommend writing it out. Okay, if you're at all like at odds or not knowing what's going on, writing it out definitely important. Definitely a good practice. Okay. It is often recommended that adults consume vegetables? Wrong. Oh, I'm sorry, bro. You're going to be cooking a lot of vegetables. No, I like vegetables. They're all right. So, okay. So this is always an equals, right? But let's look around. Dietitian would like to test the claim that the average is lower. So then what would I be putting here? Less than. You got it. So I'm going to like refresh and start from the beginning doing this here. Refresh. Okay, so H naught, HA, I know it's sloppy, but, well, 2.5, less than 2.5, that's my claim. In case someone asks, this is a left tail test, and it looks kind of like this. Yes. Oh, yes. Yes, always equal. And you can write that down in stone. That's a thing right there. Yes. Cool. And then they give us a lot of numbers. Oh my goodness. Now pause for a second. I know that, there's a lot of sliders. We need to do this. You don't need to do this. This is not part of the answer. These are the answers. That's GeoGebra. So I want to go to GeoGebra right now and put in all my numbers. So in a way, it's also learning which ones we need to put in where. Now, I'm wondering if it's a T or if it's a Z test. We were looking for sample standard deviation. Oh, population. There we go. Well, then that would be a Z test of the mean. See, the only difference between Z and T is right here, sigma versus S. S is for sample. Sigma is for population. That's something else you can write down. Greek letters, population. Latin characters, that's like English letters. Those are samples. Okay, so 2.5 less than, we got a mean of 2. Standard deviation 0.85. Sample size 30. And I'm just going to put in my numbers. So this is the Z. Again, test statistic equals Z is another like formula, I guess you could say. And your p-value, oh my gosh, is this 3 decimals? Does it say 3 decimals? It doesn't say anything about that. It doesn't say. So I'm just going to do it. I'm going to do 3 decimals and hope for the best. Of course, I would see that on the exam. 0.001 if I round it. What? Is it because it's 2 decimals? Bro, are those the... Look, they wanted 4 decimals and 2 decimals. Look, they wanted 2 and they wanted 4. Not 3 and 3. Not 3 and 2. Are you all a little upset? I mean, there's my answers right there. Like, why? It's like everyone's like walking around there. Okay. So, hi. It's good to see you. Hello. I'm in the middle of a recording. If y'all want to hang out, that's fine. I'll be done here soonish, but if not. Hi. We'll be talking. See you later. Okay. You still staring at me? So we're going back to the piece of paper. Sorry for those interruptions, guys, and for the online folks. Here we go. So we had a p-value of 0.0006, and I had an alpha of... Doesn't matter, because we definitely knocked it out of the park. Do they have an alpha for me? Oh, we have to answer this stuff. Help me out, guys. What do they want? Is it like this thing over here? Right, 6%? Greater than? I don't know. I'm going to do this. B. Okay, good. Whew. Okay, blah, blah, blah. That was no math. Okay, now we got it. Alpha right there, 0.01. So P is less than or equal to alpha. Reject H naught. So what does that look like? I reject this. So I would say yes, support the claim. Reject H naught. Yes, support the claim. Yeah. Yeah. Yep. And if you're not rejecting it, then you're saying you don't want the claim. No claim. Bad claim. Yep. So it's basically always a 50-50 at this point. We just have to know which ones are 50-50. You look cold. It is cold in here. It's actually... I saw the AC people come today just to make it colder. Yeah. Yeah, they're like, oh no, it's cold outside. We need to make it colder here. I'm like, oh, okay. No, I'm half joking. I saw them out here, but I don't know what they were doing besides making it colder, because that's what it feels like. So, okay, that's an improvement. It used to be 53, so we're definitely making some headway here. Awesome. 9 points. Yeah, so we're still in 9. Same thing. Oh, here we go. Always equals. Now let's read the rest of the problem. Test greater than. You already know it. Okay, I trust you guys. Greater than. Yay. I'm gonna still. I guess I'm gonna draw the whole thing out again. I know it's like tasking, and it's, we have to do it again and again. But this is the last time you'll have to do it ever. Think about it like that. Like one more time, then I'm done. And so there's the claim. There's a right tail test. And it looks like this. Okay, great. Just wow, you put a lot of effort in that, Chad. I know. Oh, that comes from GeoGebra. So let's go and put everything else in. If you notice, it says proportions. Proportions. So then I'm going to go to proportions. 72? No. Yeah, 72. Greater than. Sample size of 30. Oh, proportion. So we put in a 0.90. We're good? No. It's 0.90 times the 30, right? Because we need a whole number of people there. That's the main thing there. You might want to write that down. Success is P times N or N times P or something like that to kind of remind you that you have to multiply, or success is multiply percentage with total. Something like that. But after you're done, it'll convert it for you. There's my z-score. Type it in. Here we go. 2.1, 2.20. You round it. Awesome. Here we go again. I have to do it. So 1% significance. Oh, and it's a right tail test. Oh, man. Okay. I think that would be it. But look how broken that is. It's so broken, isn't it? Look. Oh, man, that's so annoying. And then we got 2.19. Here we go again. Okay, 2.20 if you round it, right? Man. Just one more day, guys. One more day, and the brokenness is done. So we got this p-value right here, and their alpha was 1%. So let me real quick go back to that. Was it here? No. It keeps confusing me. Where's my thing here? Okay, yeah. So my p was 0.01 something. What was it? 11? I can't remember. But anyways, this was only 0.1, so then the p is greater than alpha. So we're going to fail to reject H naught. And so then we say that this is good. We like this one. Therefore, bad claim. Bad claim. No support. Fail to reject. No support. There we go. Cool. Sweet. Are y'all good with that? Chapter 9 stuff? Okay, last little bit. Chapter 12, this should go real quick. Oh, no, there's another chapter 9. It's okay, guys. Just one more. Just one more, and then we're done. Equals. Yes, you're right. Different, not equal. You're right. You're right. There we go. Okay. We got this. I'm going to draw it one more time. And it is best practices to draw it, even when it's like tough. Claim, two-tail test, something like this here on both sides. Wow, that is the worst bell curve ever, Chad. Yeah, I know. They don't care about this thing at all. They want this. And so that again means I'm going right to GeoGebra. This guy. Nope. Nope. Keep clicking the wrong one. Oh, yeah. There we go. Okay, let's put in some numbers. So we had 31 not equal to 45. 0.20 times the 45. Yep, there you go. Cool. This is my Z. 560. And then the last one was 4 decimal places. I'll give them 4 freaking decimal places. Oh, finally. Woo! Maybe you want to write that one down. 2 decimals, 4 decimals. Like, oh, okay. So we have right here 11. Oh, look at that. Those are weird. What is going on? That's different than mine. I put in 11 and they say the answer is 10. Okay. Well, they're wrong. So plus and minus, right? Because it's two-tail plus and minus both sides. We already talked about that earlier. And then reject, fail, reject. So here we go. My p-value, whoa, hold on, was 11. And the alpha was how much? Do you remember? Did they say? Alpha. They got alpha somewhere. Right? No. They don't have alpha somewhere? Surely they got alpha somewhere. Oh, right there. There it is. 1%. Oh, hate when they hide these things. Anyways, p greater than alpha, fail to reject H naught. So that means we accept it, right? That means accept. We've already talked about that a whole lot. Therefore, bad claim, no support, blah, blah, blah. Fail to reject, bad claim. There we go. Oof. Whew. Now on to chapter 12. Now we're moving. Now we're cruising finally. Here we go. Okay. Oh, they're saying which one is it? It's not too bad. I almost want to just look at it, without having to go GeoGebra. I mean, you can see we got 1, 2, 3, 4, 5, and we got 4, 6, 7, 8, 9. So we got 4, 4, 6, 7, 9, 8. 4, 6, 7, 8, 9. I like that. I mean, you could do just GeoGebra, and we will here in a second, but not for that easiness there. Oh yes, gosh, man, here we go. So number 1 has got to be 40, comma 20. So this has got to be at 40, 20. Number 1, not number 2, not number 3. Do you know how many times I got this one wrong? Number 1. Now hold on, but number 2 has got to be 26, 40. So find number 2, 26, 40. Did I mix my things up? No, they're just confusing. 26, 40. Number three is 20, 50. 20, 50. Okay. Number 4. This is during your exam, by the way. You're totally taking the time to do this. Oh my gosh. I have my own opinions. I can't say them. I'm being recorded. 1070. Okay. Yes. Yay, we can click buttons. How awesome are we? Now do the math. So I don't know what they're wanting here. Estimate the percentage of this. Oh, right. 35%. And we're going to go here at 35. Go up. 35. Go over. What would that be, like 20, 28? 28, I think. Let's try 28. I mean, I definitely should actually be using GeoGebra for that. 27, whatever. If you're off by 1 decimal, I'll be adding points, but that's okay. Great. I would rather try to make it faster for you because you don't have enough time to do all the GeoGebra stuff if you don't have to. And I'm sure that we're going to use it now. Actually, no. We're just comparing here. So n equals 19. This is something to write down. Oh man, when we're at the end here, this is like the chapter 12 stuff. Degrees of freedom is equal to n minus 2. But only here. Back in chapter 9 and 8 and 7 and 6, degrees of freedom would be n minus 1. Here it's n minus 2. So we have 19. So then I'm actually going to be looking at the 17. Yes, 17 right here. So you can see that mine's much less than 45. They're saying on a curve, because we got so many people, on a curve, if you got more than 85% on your test, then you pass the class. That's what they're trying to say here, right? Did we get more than 45% on our test? No, we got 5% on our test. I'm just, but I mean, like visualizing it, that's not good, right? That's not passing, not significant. That's what I would say. And we only needed a 45 in this particular case. So I'm going to say not significant because it is between. And I can tell you why the is between. I have to use a different color. Okay. What we found was a value that was somewhere like normal. This is the usual zone, and this right here and over here are the unusual zones. Do you remember this kind of talk? So what we did, as I'm saying, this line in the sand is a 45%. Okay, a 45% on your test, and so people way over here, they're getting like 99%, right? Not many people make a 99% test. So what you made is a 5%. Is that like in the unusual? You pass the class? No. So you can see that we're between these two marks. You see that? That's the usual zone. I guess usually people fail. That's kind of sad. But I mean, just again, we're trying to keep it so you can pass this test. I'm just trying to think of it how I think about it, Okay, this one is definitely GeoGebra. There's no way around it. We have got to do it. And it's not a bad thing. It's just, obviously it takes time. So I need to go back to, yes, something like this. And I don't think we can copy paste that in. So I'm just going to, maybe I'm wrong, but I'm going to just real quick. Oh man, this is so annoying. In the middle of a test, and you're like, I ain't got time for this. No, okay. Do y'all know if it will copy paste? Yeah, not on this problem, which is like really annoying. 54, 48, 57, 53. Okay, got it. Highlight both columns, two variable regression analysis. Two variable. And then down here, make it linear. Down here, make it linear. And it should just give you the answers they want. So here they want B, which is this y-intercept thingy here. So that would be 11.2, and we're done. So pretty straightforward there. If they wanted M, then they would want this number right here, the first number. So that's mx plus b. That's something you can write down. Y equals mx plus b. So mb. So that's what they're. Oh well, there's I guess some kind of formulants of that. Oh my gosh. Well, you only have one of these, not two. So they're wanting M. Instructor cheat? You don't give it to me when I'm a student? What do you mean? You get it, right? There's more to be had, and they're not going to let me progress otherwise, are they? We got time for this? No. Oh, and then I mess it up, and it's all over. One number you mistype, it's all over. Isn't that awesome? That's what we're testing you on, right? Is your typing skills. That's statistics. I'm half joking. Data entry is a very important job, and you've got to be able to do it correctly. Okay, here we go. Two variable linear M, 3 decimals. Got it. Okay. Yeah, chat, stop being lazy, chat. Okay. All right, here we go. 29. I'm going to subtract what from it? 2. So I'm looking at 27. So on a curve, as long as you made a 37 on the test, then you pass the class. We made a 46. So that's good enough. We pass. Everything's fine. So that is a yes significant. And so yes significant. It is not between. Those are on the outsides. So that like rejection region zone or whatever you want to call it. So yes. Right. Significant is not between. Not significant is between. So I guess you have to have one not. There it is. That's the way to think about it. There's only one not. You can write that down on there. There's only one not. Because here you see there's no knots at all. And here there's two knots, not. So that's not good either. So it's literally down to a 50-50. It's always going to be one knot, either up front or in the back. Cool. That was great. I like that. That was very good. Excellent analysis. I think, okay. So we have, okay. I'm going to do this one in GeoGebra this way. There's definitely other ways to do it that are, I would say, faster, but they're more complicated to kind of like have to work around it. So I would just rather do like what we always do. Like, what do I do with this problem? I put it in GeoGebra. What do I do with this problem? Put it in GeoGebra. And it's not too bad here. Same thing. And then down here is a little thing that you can plug numbers into. So they say, what's going on at 180? So you can literally just type in 180 and hit enter, and it'll just give you the answer. That's the cool part of that one. Okay, so that's what I would recommend because it's faster in that regard. You could go to Desmos and whatever, but it would just, this is easier. So down here, you just plug in that number. So blah, 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 blah. They already give you the formula. I get it. But if you just plug in that number here, it'll just automatically give it to you. That's nice. Makes it faster. Oh, right. Remember how we were thinking, is it inside or outside of the zone? Does it work? Well, 180 is not inside of this original zone, right? So I would say that it's reliable. No. It's unreliable, but it's reasonable. Yeah. That's what I'm gonna say. So this is always the phrase unreliable but reasonable. That's always the phrase that I found whenever it's outside of the zone. So maybe like outside the zone, outside the original x values, you would say this. If it is inside, it's just reliable and reasonable. It would be both. It would just be, yeah. No, I've never had it that way. I know what you're thinking though. So yeah, I've never had it another way. It's always been reliable or unreliable, but they're always reasonable. Here in this class. Oh, did I just say that? Anyways, as far as I've seen, like when would it be unreasonable? I don't know. It would be like something way, 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 way out there, and like 180 is not. I mean, come on, it's time studying. 180 minutes versus 120 minutes. I think you'd be fine. That makes sense. If you were like doing 20,000 minutes, then yeah, that's way too far. I would not trust that at all. Okay, good questions. Outliers. Oh, I love these because you just click on them, right? No, I don't love these. So, gosh, these are like the bane for me, man. So it's that residual stuff, and I'm gonna try to remember the formula. The residual is equal to actual minus the predicted. Yes, I think that's right. Let's just verify. So it's in the thousands. The equation is this. On a particular day, we had this with a high temperature of that. What's going on? So my actual was the 3024. The predicted, I have to go and find. So this would be the 0.21 times 27 and then minus the 3.2. And I need to actually find out what that guy is in Desmos, or I guess GeoGebra if you like it, but I like Desmos better. Oh, we have Desmos up. Let's do that. Okay, so I got 2.47. But if you're noticing, that's like radically off, right? It's because this is in thousands. So technically what we actually have to do is the 2.47 times 1,000 in this particular problem. Not always, just here. They're wanting to know like in thousands how much we're talking, okay? Cool. So then what I have is 3,000 versus 2,000. So my sales were above and positive, right? Like if I take these and subtract them, I would get a positive number. I can prove it. Back to the calculator. Whoa, dyslexia. I did it again. Stop it. Positive 554. I can put that down right there. Okay, cool. So yeah, above, positive. I don't think so. Yeah, I think that's another true false kind of thing, right? So yeah, if it's below average, it would be negative always. So yeah, I like that. That's good thinking. Yeah, positive above, below negative. That's the only way that we can have that. You're right. Very good. That's good to see those things. Oh man, this is one of those again. I mean, I know that they're not like too hard, but it's just like, look, go away, go away, go away. How do I make it go away? Grr, problem. Anyways, look, and then it pops up with this other stuff. Okay, so just leave me alone. Okay. Okay, good. Okay, leave me alone. So your midterm determines what you might get on the final. So then they have this formula, midterm, and then I got this on my final. But what was I expected to get on my final? So 25 plus 0.7 times that 70. So that was again my midterm, and this will get my predicted final. That'll get my predicted final. So 25 plus 0.7 times 70. So 74 is my predicted. But what I got was a 79. Took more time, studied, I did really good. So then again, if you remember, residual is actual minus predicted. So then I add my actual minus the predicted. I have a positive 5. Positive 5. Will accept plus 5? What do you think? Of course it will. Not, I would not normally do that. Don't do it. You never know with Newton. But I mean, yes, 5. Are you all seeing what I said? That see there? Plug it into formula, get the number, and then you subtract the 2. Okay. Whew. Almost there. We got this. We got some time. Oh, last one. Okay, if I remember, how this works is you can just divide 2 numbers and walk away. It's the R and the S, or no, that's the R and the T. R over T. Isn't that how that worked? Here, let me just sideways this. SSR SST is my R squared. I think we're going to verify that, okay? Okay, I like that. That's a good phrase. Yeah. Small over big, ignore the E. I like that. That's really good. So let's try that. And again, we could definitely go to GeoGebra, but I'm thinking that y'all, we need as much time as possible. So 75025. Oh, we got one just like that. Sweet. Did it. So that's super easy. Yep, there's your formula. There's your formula. Awesome. There it is again. Let me just kind of put this on this side over here, since it'll be easier that way. 257.18 divided by 8,454, 3, 3. This one, that guy. There it is. Got it. Cool. I think that was it. Are we good? We're done here? We did it. We did it! Are y'all good? Any questions? Whew. Thank you, guys. It's been fun. It's been a great class. I really like you guys. Yeah, yeah. And now